SpaceX has been playing 4D chess with rocket science, and the Raptor 3 is their grandmaster move. They've managed to make this engine lighter than its predecessors while cranking up the power. It's like they've discovered the secret to turning lead into gold, except instead of gold, it's rocket fuel efficiency. Speaking of efficiency, let's dive into the nitty-gritty. The Raptor 3 boasts a specific impulse of 350 seconds. For those of you who dozed off in physics class, that's like saying this engine can squeeze more zoom out of its vroom than almost anything else out there. It's the fuel-sipping hybrid of the rocket world, if that hybrid could also outrun a cheetah strapped to a lightning bolt. But wait, there's more! SpaceX has pulled off a magic trick that would make David Copperfield jealous. They've managed to eliminate the need for traditional heat shields. That's right, they've told those bulky, high-maintenance heat shields to hit the road. How, you ask? Well, they've essentially turned the entire engine into one big cooling system. It's like they've given the engine a built-in spa treatment, constantly circulating coolant to keep things chill. And when I say chill, I mean not melting into a puddle of very expensive metal. Now, let's talk about the Raptor 3's diet plan. This engine has been hitting the gym hard, shedding pounds like it's trying to fit into last year's rocket fairing. At just 1,525 kilo, it's 36% lighter than the original Raptor and 7% lighter than Raptor 2. That's like if you lost a third of your body weight, but somehow got strong enough to bench press a small country. But here's where it gets really wild. Despite this dramatic weight loss, the Raptor 3 is pumping out 51% more thrust than its great-grandpappy Raptor 1 and 21% more than its older sibling Raptor 2. It's like SpaceX engineers found a way to break the laws of physics, or at least bend them until they cried uncle. This brings us to the holy grail of rocket engine metrics, the thrust-to-weight ratio. Brace yourselves, because the Raptor 3 is sporting a mind-bending ratio of 184. To put that in perspective, it's like if you could lift 184 times your own body weight. Suddenly, those gym bros bragging about their deadlifts don't seem so impressive, do they? But SpaceX isn't content to rest on their laurels. Oh no, they're already hinting at squeezing another 8 to 10% more thrust out of this beast. It's like they're trying to turn the laws of physics into a pretzel, and somehow, it's working. But let's not get too caught up in SpaceX's magic show. How does the Raptor 3 stack up against the competition? Well, buckle up, because we're about to leave them in our cosmic dust. Take Blue Origin's BE-4 engine, for instance. It's like comparing a sports car to a rocket-powered supercar. The BE-4 puts out a respectable 2.4 million newtons of thrust, but the Raptor 3 leaves it eating space dust with 2.75 million newtons. It's not even a fair fight, folks. It's like bringing a knife to a laser sword duel. But what about the venerable RS-25, the powerhouse behind the space shuttle? Surely that can give our Raptor a run for its money, right? Well, not so fast. While the RS-25 boasts an impressive specific impulse of 366 seconds at sea level, it's lugging around a thrust-to-weight ratio of only 73. The Raptor 3, with its svelte figure and powerlifting capabilities, more than doubles that with a ratio of 1 to 84. It's like the RS-25 skipped leg day, arm day, and pretty much every other day at the rocket gym. Now, you might be thinking, but the RS-25 uses hydrogen fuel. That's got to count for something, right? And you'd be correct, hypothetical viewer. Hydrogen fuel typically gives you a higher specific impulse. But here's where SpaceX pulls another rabbit out of its hat. The Raptor 3 uses methane, which is like the middle child of rocket fuels. Not as energetic as hydrogen, but a whole lot easier to handle. Yet somehow SpaceX has coaxed a specific impulse of 350 seconds out of this methane-guzzling monster. That's like getting sports car performance out of a minivan. But the real secret sauce? It's all in the plumbing. The Raptor 3 uses what's called a full-flow staged combustion cycle. Now, I know that sounds like something you'd find in a laundromat's instruction manual, but bear with me. This cycle is the holy grail of rocket engine design. It's so complex and difficult to pull off that before SpaceX came along, it was more theoretical than practical. It's like SpaceX decided to play rocket engine Jenga, but instead of removing pieces, they're adding them in ways that shouldn't work, but somehow do. And the result? A cooling system that's more integrated than peanut butter and jelly. Let's break it down. Traditional rocket engines have heat shields that are about as subtle as a sunburned tourist on a beach. They're bulky, high maintenance, and frankly, a bit of a drag. But SpaceX looked at those heat shields and said, "Nah, we're good." Instead, they've turned the entire engine into one big cooling system. Imagine if your car's radiator wasn't just under the hood, but was the hood, the engine block, and pretty much every other part. That's essentially what SpaceX has done with the Raptor 3. They've created a network of cooling channels that would make a water park designer jealous. These channels run through the engine like a labyrinth, carrying cryogenic propellants that keep everything cooler than a penguin's picnic. But here's where it gets really wild. SpaceX isn't just using any old manufacturing techniques to pull this off. Oh no, they've gone full Tony Stark and are using advanced 3D metal printing technology. It's like they've taken a page out of a sci-fi novel and decided to make it reality. This allows them to create complex internal structures that would make a Swiss watchmaker weep with envy. The result? An engine that's more efficient than a coupon-clipping grandma and more powerful than a caffeinated bodybuilder. By eliminating separate heat shields and fire suppression systems, they've not only reduced weight but also simplified the entire engine architecture. It's like they've Marie Kondo'd rocket engine design, keeping only the parts that spark joy and thrust. But wait, there's more! This simplified architecture isn't just about making things lighter, it's about making the Raptor 3 more reliable and easier to reuse. Fewer parts mean fewer things that can go wrong, and easier inspections between flights. It's like SpaceX has created the Toyota Corolla of rocket engines. If that Corolla could also break the sound barrier and punch through the atmosphere. Now, you might be wondering, how on Earth, or off Earth, did they manage to pull this off? Well, it all comes down to some seriously clever engineering and materials science. They're using alloys and composites that can withstand temperatures that would make a volcano feel chilly. We're talking about materials that laugh in the face of extreme heat and pressure, all while being lighter than your average smartphone. It's like SpaceX engineers went to a sci-fi convention, saw all the fictional supermaterials, and said, "Hold my rocket fuel." Take Inconel, for instance. This superalloy is to regular metal what Superman is to your average Joe. It's got more nickel than a coin collector's wildest dreams and can withstand temperatures that would make the surface of the sun feel like a cool spring day. SpaceX is probably using some version of this wonder material in the Raptor 3, because when you're dealing with temperatures hot enough to vaporize diamonds, you don't mess around with bargain bin alloys. But Inconel is just the appetizer in this materials science feast. Let's talk about ceramic matrix composites. These bad boys are like the ninja warriors of the materials world. Lightweight, tough as nails, and able to withstand ridiculous amounts of heat. They're what you'd get if you crossed a ceramic coffee mug with Kevlar body armor, then gave it superpowers. SpaceX is likely using these composites in areas of the engine that see the most extreme conditions, because when your job is to contain a controlled explosion, you need materials that can take the heat and stay in the kitchen. Now here's where things get really wild. SpaceX isn't just using fancy materials. They're making them in ways that would make a 3D printing enthusiast weep tears of joy. They're using advanced additive manufacturing techniques that are less like traditional manufacturing and more like something out of a Star Trek replicator. Imagine if you could 3D print not just plastic trinkets, but complex metal structures with internal cooling channels more intricate than a plate of spaghetti. That's essentially what SpaceX is doing with the Raptor 3. They're printing parts that would be impossible to make any other way, with internal structures that look like they were designed by a geometry-obsessed alien race. This 3D printing wizardry allows SpaceX to create parts with geometries so complex they make M.C. Escher paintings look like stick figures. We're talking about cooling channels that twist and turn like a roller coaster designed by a madman, all packed into a space smaller than your average coffee mug. It's like they've found a way to fold space itself, but instead of bending the fabric of the universe, they're bending metal to their will. But why go to all this trouble? Well, it's not just because it looks cool, although, let's be honest, it does. This advanced manufacturing allows SpaceX to create engine components that are simultaneously lighter, stronger, and more efficient than anything made with traditional methods. It's like they've found the holy grail of engineering, a way to have their cake and eat it too, if that cake were made of high-performance rocket parts. The result of all this materials magic and manufacturing mayhem? An engine that's pushing the boundaries of what we thought was possible. The Raptor 3 is like a greatest hits album of cutting-edge technology, all working together in a symphony of controlled explosions and precisely managed heat. But here's the kicker. SpaceX isn't content with just making a better engine. Oh no, they're aiming to revolutionize space travel itself. With the Raptor 3, they're not just reaching for the stars. They're planning to give them a high five when they get there. This engine isn't just about going to space. It's about making space travel as routine as your morning commute. Well, maybe not quite that routine. Let's face it, even with the Raptor 3, you're not going to pop up to the moon for a quick latte, but it's getting us closer to that sci-fi future we've all been dreaming about. Let's talk launch costs. Right now, getting anything into orbit is about as expensive as trying to mail your house to Mars. But the Raptor 3 could change all that. With its incredible efficiency and reusability, we're looking at a future where launches could be as frequent as subway departures. Okay, maybe that's a bit of an exaggeration, but you get the idea. We're talking about a dramatic reduction in cost per kilogram to orbit. It's like going from first-class airline tickets to budget space travel. And speaking of reusability, the Raptor 3 is designed to be the Toyota Corolla of rocket engines, reliable, efficient, and able to keep going long after others have called it quits. SpaceX is aiming for a turnaround time that would make a pit crew jealous. We could be looking at engines that can fly multiple times a day with minimal refurbishment. It's like they've taken the concept of a reusable grocery bag and applied it to rocket science. But let's dream big for a moment. Mars, the red planet, that dusty ball of potential that's been teasing us since we first looked up at the night sky. The Raptor 3 could be the key that finally unlocks the door to Mars colonization. With its high thrust and efficiency, we're talking about missions that could carry more payload, get there faster, and maybe even bring some stuff back. It's like the difference between packing for a weekend getaway and moving your entire house. Suddenly, we've got options. Now I know what you're thinking. But what about all that radiation in space? Won't we all end up looking like extras from a B-movie sci-fi flick? Well, fear not, intrepid space explorers. The increased payload capacity means we could send up better shielding, more supplies, and maybe even a few creature comforts. We're talking about missions that could make a Mars stay feel less like a camping trip from hell and more like an extended stay at a very red, very dusty resort. But it's not just about Mars. The Raptor 3 could open up possibilities for all sorts of new mission profiles. Want to send a probe to the outer solar system? How about a fleet of them? With the Raptor 3, we could be looking at missions that make our current space exploration efforts look like we've been playing with toy rockets. We're talking about the potential for larger space stations, more ambitious deep space missions, and maybe even those space hotels we've been promised since the 1960s. It's like the Raptor 3 is the key to unlocking a whole new level in the video game of space exploration. But here's where things get really interesting. The Raptor 3 isn't just going to change SpaceX's game. It's going to light a fire under the entire aerospace industry. You think other space agencies and companies are just going to sit back and watch? No way. They're probably already scrambling to catch up, like a bunch of kids who just realized their friend got the latest gaming console before them. NASA, ESA, Roscosmos, they're all going to be feeling the heat. And let's not forget about the other private players like Blue Origin and Virgin Galactic. It's like SpaceX just raised the stakes in the world's most expensive poker game, and now everyone else has to decide whether to fold or go all in. This could lead to a new space race, but instead of just two superpowers duking it out, we're looking at a free-for-all with multiple countries and private companies all vying for a piece of the cosmic pie. It's like the Wild West. But instead of cowboys and gold rushes, we've got rocket scientists and Martian land claims. And speaking of Mars, let's talk timelines. Remember when getting to Mars seemed about as likely as finding a unicorn in your backyard? Well, the Raptor 3 might just be the horn on that unicorn. With this kind of technology, those far-off estimates for Mars missions could get a whole lot closer. We might need to start packing our bags sooner than we thought. But it's not just about getting there faster. The Raptor 3 could change what we can do once we're out there. Imagine setting up a permanent base on the moon or Mars. With engines like this, we could send larger habitats, more supplies, maybe even the materials to start manufacturing stuff in space. It's like going from sending a postcard to shipping an entire IKEA store. Now, I know what you're thinking. This all sounds great, but what about the challenges? Surely there must be some downsides. And you'd be right, hypothetical viewer. We're still talking about rocket science here, not a walk in the park. There are plenty of hurdles to overcome. For one, there's the small matter of keeping humans alive in space for extended periods. The Raptor 3 might get us there faster, but it can't magically solve the problems of radiation exposure, bone density loss, or the psychological effects of long-term space travel. It's like having a super-fast car but still needing to figure out how to survive a cross-country road trip without going stir-crazy. Then there's the question of funding. Sure, the Raptor 3 might make launches cheaper, but space exploration is still eye-wateringly expensive. We're talking about projects that make Hollywood blockbuster budgets look like pocket change. It's going to take more than just cool technology to convince governments and investors to keep footing the bill. And let's not forget about the environmental concerns. While the Raptor 3 is more efficient than its predecessors, we're still talking about burning a lot of fuel to get off this rock. As we push further into space, we'll need to keep a close eye on our impact both on Earth and on the celestial bodies we visit. We don't want to solve our problems here just to create new ones out there. But here's the thing. Challenges drive innovation. The problems we face in expanding our presence in space are the very things that will push us to come up with new solutions. It's like how the space race of the 60s gave us everything from memory foam to cordless vacuums. Who knows what world-changing technologies might spin off from our efforts to overcome these new hurdles. In the end, the Raptor 3 isn't just an engine. It's a symbol of what we can achieve when we push the boundaries of what's possible. It's a reminder that even in a world that sometimes feels like it's spinning out of control, we're still capable of reaching for the stars. Literally. So, the next time you look up at the night sky, remember that those distant pinpricks of light aren't just pretty decorations. They're destinations. And thanks to innovations like the Raptor 3, they're destinations that are getting closer every day. Who knows? Maybe in a few decades you'll be booking your summer vacation to the Sea of Tranquility instead of the beach. Just remember to pack your sunscreen. I hear the UV rays are killer up there. As we wrap up this deep dive into the Raptor 3, I can't help but feel a sense of excitement about what's to come. We're standing on the brink of a new era in space exploration, and engines like the Raptor 3 are the keys that will unlock the door to that future. It's like we're characters in a sci-fi novel, except this time the story is real, and we're all part of it.